Okay, here we go. We're going to do solving inequalities. Practice test number 2. Here we've got negative 10 is less than or equal to negative 5y. We're going to look at the side that y is on. We want to get rid of that negative 5. Negative 5 and y are multiplying themselves together. So we're going to undo that by doing the opposite, which is division. We're going to divide both sides by negative 5. The negative 5 and the negative 5 cancel out. We end up with the y. Negative 10 divided by negative 5 is a 2. But instead of writing the same inequality sign, the inequality sign flips because we just divided by a negative number on both sides. So we'll look at the number line. We'll put a 2 there. We have two decisions to make, whether we do an open or closed circle or whether we shade to the left or to the right. Because we have an equal sign, well, part of an equal sign underneath this sign, we're going to fill in our circle. And then when we read this, we're going to read from the y side first. When we read it, we're reading y is less than or equal to 2. So let's think about the numbers that are less than 2. The numbers that are less than 2 are on this side of the number line. And once again, the reason why we fill this in is because the solution to this problem can be equal to the number 2, or it's going to be any of these numbers that are less than 2. For number 2, we're going to go ahead and get rid of the minus 4 by adding 4 on both sides. We'll bring down the 3x. We'll bring down the greater than sign. 11 plus 4 is 15. We're going to undo this multiplication between the 3 and the x by dividing. We're going to divide by 3 on both sides. Now, don't get caught into the mistake of thinking anytime you divide, you need to flip your inequality sign. You don't. In this case, we're dividing by a positive number, so our inequality sign stays the same. So I see that I have a 5. That means I go to my number line. I place a 5 by one of the tick marks. I notice that I don't have an equal sign underneath, so it's going to be an open circle. And when I read it, I'm going to read from the x side first. So this says x is greater than 5. I think about the numbers that are greater than 5, and those are numbers like 6 and 7 and 8, all the numbers on this side. Once again, all the solutions are greater than 5, and that's why there's not a filled in circle, because 5 is not part of the solution. Okay, and this is getting a little more complicated, and I think about DC-GAM, right? Distributive property, combining like terms, gathering your x's on one side, addition or subtraction, multiplication or division. That's DC-GAM. That's the order that we're going to solve an equation, and the same order we're going to use to solve an inequality. So the first thing I notice is that I've got like terms on one side of the inequality. I'm going to go ahead and add those. 2p plus 2p is 4p. I'm going to bring everything else down because I only do one step at a time to make sure I don't make mistakes. Now I want to gather the p's on the same side. So I see this 4p, and when I want to move it, I'm going to do the opposite. So since, I don't know why I wrote a 5, since it's a 4p, I'm going to do the opposite. It's positive 4p, I'm going to subtract it from both sides. Sometimes people get confused, but it's pretty easy. If I subtract a 4p from 4p, it's gone, and that's what I wanted to do. If I made the mistake of adding a 4p to this side, well, that just would have given me 8p on the side. I don't want anything. This is gone. So that's how you can test yourself if you're right or not, to make sure that it's actually gone. I bring down the negative 7. 3p minus 4p is negative p. I could also write a negative 1p, and I bring down the minus 5. Now I want to get rid of the minus 5, so I add it to both sides. I bring down my negative 1p. It's gone, right? Negative 5 plus 5. I bring down my greater than sign. Negative 7 plus 5 is negative 2. Now to get the p alone, I have to divide both sides by a negative 1, and the bells are going off, right? Because we divided both sides by negative 1, which means not only does do the negative 1's cancel out, and negative 2 divided by negative 1 is 2, but this sign that used to be a greater than sign is now a less than sign. So we take this number, we see our number line, we're going to put a 2 by one of the tick marks, and we read it again. It says p is less than 2. So it doesn't say it's less than or equal to. So since there's no line underneath the less than sign, I have to do an open circle. And because it's less than, I think about all the numbers that are less than 2. And those numbers are 1 and 0 and -1, all the numbers to the left. With number 4, I want to gather my x's on the same side. If I chose to move my -4x to the other side, I would end up with nothing on this left side, and that might get confusing. So I'm going to take my 2x and move it to the left side. Once again, I know I did it right because 2x minus 2x is gone. So -4x minus 2x is -6x. I bring down the less than sign. I bring down the 12. And to get the x alone, I'm going to go ahead and divide both sides by -6. Yes, the warning bells are going off again because since I divided both sides by a negative, my less than sign flips to a greater than. I look at my number line. I go ahead and put a -2 on one of the tick marks. It says x is greater than -2. It doesn't say greater than or equal to. So since that line isn't there, I have to do an open circle because -2 is not part of my solution. X is greater than -2. So all the numbers that are greater than -2 are way over here, like 5 and 10 and 100. With number 5, here's my compound inequalities. I'm going to write it again here so I can work a little bit easier. Here's what I always tell my students. I always say, act like that's not there. Cover it up with your hand. Okay, I was covering up with my hand, but you guys couldn't see it. And so if you cover up that part and you just look at what's left, you can go, okay, I know to solve for x, I'm going to go ahead and add 13 to both sides. I can do that. But then, all right, I got to undo my hand, which means I really have to rewrite it. So I'll put that 5. I'm like, surprise, really, there is another side, and that's a 5. So I'm going to go ahead. Look what I did. I added a 30 instead of 13. Okay. Whew, I got to pay attention, don't I? So I'm going to add a 13 to this side as well. So I'm actually solving 2 inequalities at the same time. So here I go. 5 plus 13 is 18. The -13 and 13 is gone. Then I'm going to bring down the 3x. Bring down the less than sign. 20 plus 13 is 33. Then once again, I'm just going to cover up this part, okay, with my hand, but you can't see it if I put my hand over there. So I'm going to solve for x now, and I'm going to say, well, to solve for x, to get x by itself, I have to divide both sides by 3, and then I'm like, oh, surprise, that's not really covered up. There really is this right here. So I've got to divide this side by 3 as well. And so the 3's cancel out, and I end up, I know a lot of you aren't comfortable with improper fractions like 5/3, so technically you could go ahead and look in your calculator. Well, you don't really need to. Let's just get comfortable with it. You could change this to a decimal if you wanted to, but what you're going to do is you're going to ask yourself, who's smaller, 5/3 or 11? So maybe you would want to change 5/3 into a decimal so you could compare them. Why don't we do that? So I'm going to take my calculator, and I'm going to do 5 divided by 3. And I'll get 1.67. I'm just going to go ahead and just put 1.6. And so it's obvious that 1.6 is way smaller than 11. Now note, our tick marks aren't going to be like perfectly spaced from 1.6 to 11, and that's okay. We're just putting them apart from each other, and now what we're going to do is we're going to look at this x in the middle, and we're going to read it. It says x is less than 11. So I go over to the 11. Less than means not less than or equal to, so I have to have an open circle. And less than are all the numbers like 10 and 9 and 8. And I'm going to stop because I'm going to see what's happening with the 1.6. So now I look at it this way. X is greater than or equal to 1.6. So I see that equal to sign. We haven't seen that in a while. It's half of an equal sign. That means I'm going to fill in the circle here. And then greater than means I'm going to move to the right because all the numbers that are greater than are to the right. So can we kind of see we're going to bounce back and forth off these. And this is my answer. This is the solution for all the numbers that are less than 11 and greater than or equal to 1.6. Now, I saw somebody yesterday in class doing the same problem, but they did it differently. And I thought, I want to do that on my video so that anybody who struggles with this method has a second method. And the way she did it was this. She took this inequality and she wrote it down. Then she looked at this inequality and wrote it down. So instead of having to solve both of them at the same time, she solved them both separately. We're going to do this real quickly so you guys can see. Okay, what's going on here? Let's see, 5 is less than or equal to 3x minus 13 plus 30. Okay, we're getting a different answer, so that might mean that I made a mistake on here. So I'm getting 6 instead of 1.6. So I'll go backwards and see what happened because I must have made a mistake at some point. Plus 13, so it's going to be 3x is less than 33. And we're going to get that x is less than 11. So we got the same thing except for instead of 1.6, we got 6. And now I do know what I did wrong. I'm going to go ahead and undo because you guys can freeze this if you want to and make notes. But I know what I did. I did not subtract that or add that 13 to both sides, did I? So let's see. Let's go back to the original problem. So I'm undoing my work so I can get back to the original problem. Oh, there it is. And yes, that's true. Look at my mistake that I did. You probably were, telling me, Miss Overby, you made the mistake. And I did. Look, I put 5 plus 13, and I guess I was so busy talking that I forgot to add them. I said 5 plus 13 is 5. So no, that's 18, and we would get the same answer. Instead of the 1.6, we would get 6. So see, even I make mistakes, and that's okay. We corrected it. All right, so let's change this to it's 6. Just goes to show how easy it is to make mistakes even when you know what you're doing. All right, so here we do have 2 separate inequalities, so we'll go ahead and solve those. I'm going to bring this down. I'm going to go ahead and solve for x by subtracting 5 on both sides. And then for this one, I'm going to solve for x by subtracting 5 from both sides as well. Okay, so I've got 2 things to consider. And my solution is either greater than 1, either x is greater than 1, or my solution is x is less than 6. Can you be both greater than 1 and less than 6? Yeah, you can, because guess what, Miss Overby? It's not an or, it's an and. That's like, wait a minute, this is an and, isn't it? Okay, so let's go ahead and put our 1 here and put our 6 somewhere over here. And it says x is greater than 1. So I go to my 1, I have an open circle. Greater than means I move to the right, like for 2 and 3 and 4. I'm going to stop here because I want to see what's going on with the 6. This says x is less than 6. I've got an open circle, and less than means the numbers to the left. So an and normally looks like this, where we're bouncing back and forth between 2 values. Okay, now we have an or, because an or looks completely different. So let's go ahead and divide both sides by -4, and we note, oh my goodness, we divided both sides by a negative. We've got to flip the inequality sign. And then let's go ahead and solve the second part. We subtract 4 from both sides. We divide both sides by 2, and we get x is less than 3. The sign doesn't change because although we divided by a positive number. All right, so we're going to ask ourselves which number is smaller. -4 is smaller. We'll put 3 over here somewhere. Let's look at this. X is greater than negative 4, which means it can't be equal to negative 4. It's got to be an open circle. X is greater than looks this way. It's an or, and it's going, this is very interesting. This or is looking like an and, isn't it? Okay, that's fascinating. Okay, so x is greater than negative 4, or x is less than 3. Okay, so this is what's going to happen. When you have an or like this, it's going to look a little different because and meant that it has to be both. Okay? Or means it has to be either. So a number can be greater than negative 4. I can go all the way past this 3. Okay? Or it's x is less than 3. So less than 3, I would have an open circle, and I'd go this way. But can you see when we have an or, most of the time, ors look like this. You know, like this, going this way. Maybe this one's filled in, going this way. This is a very unusual or. Sometimes we can have them like this, where it's going to be the whole number line is covered. So let's talk about that real quickly. Let's go back to this one. See how it was an and? That meant both things had to be true. X had to be greater than 1, and x had to be less than 6. So and meant they both this and this had to be true for a number to be in the solution set. This one is an or. Once again, it looks a little bit strange. We haven't seen an or like this, but it's okay. Ors can look like this. Here's another or. Let's see what this one looks like. I'm going to rewrite. I'm going to go ahead and get my h's on the same side. I'm going to go ahead and move my 7 over to get rid of it. And I'm going to go ahead and divide by negative 3, which since it's negative, my sign flips. Then I'm going to do the other side. And once again, I'm in an or. So 1/2 h plus 8 is greater than or equal to 9. We have a couple ways that we can do this. We can distribute the 1/2. And in fact, I'm going to do it that way. That's a safe way to do it. We're going to just distribute 1/2 times h is 1/2 h. Then 1/2 times 4, I'm sorry, 1/2 times 8 is 4. Then we're going to get rid of the 4. So we have 1/2 h is greater than or equal to 5. I know a lot of people in my class are much more comfortable with getting rid of a fraction by dividing by the fraction. We have a choice. We could multiply both sides by the reciprocal, so we could multiply both sides by 2. I'm going to do it this way just because a lot of you like doing it this way. If you put 5 divided by the fraction 1/2 in your calculator, you would actually get 10, and look at me putting that equal sign there. It's not an equal sign, is it? It is a greater than or equal to. All right, so let's stop here for just a second. I want you to notice a few things. One, that was a lot of work, right? And 2, we've got 2 values to look at and consider where they go on the number line. So we see h is less than negative 4. So negative 4 is the smaller of the 2 numbers. We'll put negative 4 here. We'll put 10 here. And then let's read it. H is less than negative 4. We have to have an open circle there. Less than is to the left. And then h is greater than or equal to 10. So we have a closed circle on 10. And greater than is this way. So this is a typical OR problem. And I don't know if you noticed when we've been doing all of this solving inequalities, we're really getting really great at solving equations. If you're one of those students who needs to still do a retake for solving equations, now's a good time to do it because we've been practicing and practicing the same skills that are going to help you do well on your retake. All right, and now we're switched to absolute values. Once again, we talked in class about absolute value means how far is something away from 2 on the number line. And so we think about this blob right here, and this blob can be, whatever's in the absolute value, I'm going to call a blob. This blob can be equal to 2 because 2 is 2 away from 0. on the number line. But this blob can also be equal to -2, because -2 is also 2 away from the number line, or 2 away from 0 on the number line. So there are 2 ways to be 2 away from 0. You can either be equal to 2 or be equal to -2. So once we do that, we're going to solve these simple equations. Now we are back into equations. So either x is equal to 0 or x is equal to -4. I have to use an or, because if I used an and, that would be impossible, right? I can't have a number both be equal to 0 and -4. But we can say our solution is either 0 or -4. Both of them are solutions, but you can't use an and. Hope that made sense. All right, here we've got -3 in our way. Can you see that we can't solve the absolute value when we have something outside of the absolute value? We've got to get rid of it. We're going to go ahead. We're technically dividing the whole side by -3, and we'll divide the other one by -3. What we have left is this. Now remember, we're not in an inequality, so we don't have to worry about switching any signs. There is no inequality sign to flip. But now I've got this blob in my absolute value sign that is 4 away from 0. So either that 4 away from 0 is 4, or that 4 away from 0 is -4. That's why we always set up whatever's in our absolute value sign equal to both the positive and negative number that's on the right of our equal sign. So let's go ahead and solve it. And we see that either our solution is 3 or our solution is -5. We have 2 answers. Okay, did I skip 11? I thought it did. All right, here we've got this -5 that's in our way. We cannot move forward unless we get the absolute value sign alone. So I've got 2 ways to be 45 away from 0. 9x can be 45 away from 0 by being equal to 45, and 9x can be 45 away from 0 by being equal to -45. And I'm going to simply solve these. So our answers, our solution is either 5 or our solution is -5. All right, here's 12. We're going to get rid of that 2 by dividing both sides by 2. And when we do that, the 2's cancel each other out. I end up with just the absolute value of 12x minus 6. And 60 divided by 2 is 30. So once again, we're going to set up what's inside the absolute value sign equal to exactly what's there, the 30. Or we can get a solution by setting up what's in the absolute value sign and setting it equal to -30. And then all we're going to do is solve our equation. So we're going to add 6 to both sides. So we'll get 12x equals 36. We'll divide both sides by 12. So we'll get x equals 3. Or, let's solve this side. We're going to add 6 to both sides. So 12x is equal to -24. We'll divide both sides by 12. And we'll find out that the other solution is -2. Okay, and we've got another one, 13. How many of these absolute value ones do we have? Okay, lots. So let's keep practicing. We're going to go ahead and get our absolute value by itself. Then we're going to set up our 2 equations. Now, some people might want to try solving this at the same time, like doing, oh, let's subtract 2. Let's go and subtract 2 over here. No, 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 no. Solve one equation, then come back and solve this equation, okay? That's just a recipe for disaster, to try to solve both equations at the same time. Okay, we're going to divide both sides by 4, so we get that x is equal to 7, or we're going to come over here. We'll get 4x equals -32. All right, so we've got x equals 7, or x equals -8. And one more absolute value sign. Oh my goodness, we haven't seen this before, have we? Okay, let's look at what this really says. This says the absolute value of negative 5x plus 10 is equal to negative 50. Okay, that's crazy. Think about the number line. What it's really saying is this blob, negative 5x plus 10, is negative 50 away from 0. Now I know where 50 away from 0 is, right? It could be at 50 or negative 50, but a distance of negative 50 doesn't exist, at least not in our time, right? We can't say that, oh, I was so tired, I only ran negative 5 miles. No, the smallest distance that we can measure right now in our day and age is 0. We don't have negative distance. So when you see this, if you see this, you're like, no solution. There's no number I could put in there to make an absolute value be equal to a negative number. So that was kind of fun. All right, and the last section of the test is about riding inequalities. So 15 says, in order to ride a specific ride at an amusement park, you must be at least 36 inches tall, but less than 60 inches tall. So there's a couple different ways you can go about it. Since the number line is here, and they give us these numbers, so we're going to have to put in some extra ones, like, okay, that's 36, and then it goes all the way to 60. All right, there's 60. I can tell that I'm going to be somewhere in between 36 and 60, right? You must be at least 36 inches. If you're 36 inches, can you go on the ride? Sure. So our 36 is going to be filled in because that's part of our solution. If you are 60 inches tall, can you go on the ride? Sure you can. So we're going to fill that in. Now we need to decide on the shading. So if you are, let's figure this out. If you are 33 or 34 or 35 inches, will you be able to ride on this? No, you won't. So I can't go this way. No, I can't go that way. You've got to be taller than 36 inches, so I can go this way. Okay. Now let's think about 60. If you are 61 or 62 or 63 inches tall, can you go on this ride? No. The tallest you can be to go on the ride is 60. So I can't shade that way. So I can only shade in between these two heights. And when I think about what I drew, so I'm going to get rid of these no's so that doesn't confuse you. X is stuck in between. X is stuck in between 36 and 60. It is greater than or equal to 36, but less than or equal to 60. If you wanted to separate this, we would accept it. If you wanted to say X is greater than or equal to 36 and X is less than or equal to 60, you could write it that way as well. That would be fine. Okay, the basketball team's scores. The basketball team scores, okay, at least 20 points per game. So they can score 20 points, they can score, let's just talk about, can they score 21 or 22 or 23? Sure, they can score all the way up to, 100 million. I don't think they really could, but okay. But they're going to score greater than, or they're going to score at least 20 points. Can they score exactly 20 points? Yes, they can. So they're going to score greater than or equal to 20. That means we're going to have this filled in, and greater than is to the right. At what ages are you not in high school? This one's a little tricky. Let's just say, what ages are you typically not in high school? So let's see, when you start as a freshman, are you 15 yet? No, some people are 15, but there are a lot of people who are 14. Typically, you can't be under 14. So we'll go ahead and circle this. You can be 14 and still in high school. And then most people graduate at 18. Are there some who are super seniors? Yes, but we're going to look at typically. They typically graduate at 18. Okay, so I'm actually not answering this right? Because I'm answering typically in high school. This would be the answer in high school. I'm going to do the opposite. So in high school, it would look like this, from 14 to 18. But that's not what this question asked me, right? The question asked me, at what ages are you typically not in high school? So we're going to do the exact opposite. I'm not going to include 14 because when you're 14 you can be in high school. I'm not going to include 18 because you can be in high school at 18. But when you're younger than 14 and when you're older than 18, you're typically not in high school. Well, unless you're a teacher. Ha ha ha. Okay, so this problem had some holes in it. I think the ones on the test are going to be just logic proof. They will make sense. And that's it. So study, study, study. I look forward to seeing you in class.